What's up, guys? Vylocity here with Pitchfork Academy, and I'm extremely excited to be bringing you the first of many Unreal Engine 5 material tutorials. Materials are such an exciting part of Unreal Engine 5 and can really help take your project to the next level or set it apart from others. If you're interested in learning more about materials and all of the cool things that you can do with them, make sure to leave a like and subscribe, and then let us know down below in the comments what kind of material you're interested in learning about most. In this first tutorial, I'll be covering the basics of the material graph and the most common nodes that we'll use across multiple materials, and then in the following tutorials, we'll go more in depth into master materials that we can use for various objects in our scene. Alright, once we open the Unreal Engine 5 launcher, we want to go ahead and click the first person template because we want to use this gun that has some good textures that we'll eventually be using in our material. I named mine tutorial time. You guys can name it whatever you want. Go ahead and click create. I've already done this, so I'm going to skip ahead now to the engine. All right, now that we're in the engine, we can go ahead and create a folder for materials. I've already done this here. Basically, you just want to right click, new folder, name it materials, and then let's head on into that folder. To start off, we just want to right click, click material, and a good naming convention for materials is simply M for material underscore, and we'll call this test. M test. Go ahead and click that, open it up, drag it onto my screen here, make it full screen. All right, so when you first open the material graph, there's this big node that looks pretty daunting, but don't worry, we'll only focus on about the first half of this node for now, and then in other videos, we'll probably go more in depth with things such as world position offset, subsurface color, refraction. We're not going to work with decals today, so I'll switch it back from translucent to opaque, and I'll switch the material domain back to surface. Now you'll notice in here there's a lot of other options as well, things like post-process, user interface, because materials really are super dynamic. It can be used for all sorts of things in the engine. But today we're just going to scratch the surface, and we'll be working with a surface material with the opaque blend mode and the default shading model. Now let's go ahead and go down the list here and just talk briefly about some of these inputs. Base color is exactly what it sounds like. It's all of the color information for your material. This can include solid colors, or textures that we can bring in and plug right into the base color. Metallic is a value between 0 and 1. It should always be a value between 0 and 1, and usually it's just a value of 0 or 1. Most surfaces in the real world are not halfway metallic, they're either not metallic or metallic. The next value here is specular. This value usually remains unchanged, and it simply determines how much light that the object can reflect. Roughness is one of the most important inputs. In some other programs, this is called smoothness. Basically, a value of 0 is fully smooth and a value of 1 is fully rough. We can actually visualize that now. If we type in 0 here, you'll see the sphere on the left becomes extremely shiny. And if we put a value of 1, you can see there's hardly any reflection now. We'll set that back to the default value of 0.5 for now. Anisotropy, this basically has to deal with the stretching of the reflections across the surface. This is useful for things like hair or the bottom of a frying pan where you see that strange reflection that kind of has the radial effect to it. The next input is one of the most fun inputs. This is emissive color. It's very similar to base color in that it can take a color, it can take a texture, it can even take just a value between 0 and 1, or you can go higher than 1 and set it to something like 10 or even 100 if you really want to blind somebody. The normal input is for a normal map texture, and basically this allows us to fake shadowing details on the surface instead of actually changing the geometry to get the shadows. The rest of these inputs aren't very important to us yet, and we'll go more in depth with them in later videos. All right, to start making a material, we need to get out some common nodes that we'll use throughout most materials. So first we want to get a 3 vector. So if I search 3 vector, we'll get a constant 3 vector. This is a color. As you can see, it starts as black, but if I double click it, I can go ahead and set it to green. Click OK. If I plug this right into base color, you can see instantly we get a green sphere here. All right, so another common node that we'll need is a 1 constant. So if I search for constant, we have a single value here that we can use to plug straight into one of these outputs, or we can even use it to multiply a node with another node. So for example, if I multiply this color by 0, it becomes black because anything multiplied by 0 is 0, and 0 in this case, since we're working with color, is going to be black. Now, if I multiply it by 1, you'll see it's the exact same color. For now, we're just going to keep the color on its own, and we can delete this multiply. All right, now that we have this single value by itself again, we can start putting it into these other outputs to see what happens. If I drag a 1 into metallic, you can instantly see that the surface starts to look a little bit more like it is a metallic surface. And if we go ahead and copy, duplicate this node here, and we plug it into roughness, you can see now we have basically no reflections at all. But if we set this to 0, we get a very cool material, which is basically an extremely shiny version of metal. All right, this next output that we're going to be going over is emissive color. If I just drag the same color we're using as base color into this, it should look very similar, but be a little bit brighter. Exactly. Now, we can try to multiply again, and we'll get another constant. We'll use these to multiply them together. Now, remember, if we multiply it by 0, there will be absolutely no difference. And then 1, we'll get the same effect that we had just by plugging the color straight in. But since we have this multiply available to us now, we can push this value above 1 into an extreme number such as 10 or even 100. You can instantly see that we have this very bright glowing sphere. Now, usually we won't put this value above, let's say, 5 or 10, unless you're really going for an effect that looks like something is really glowing, such as a sun in the solar system or a very bright light that's supposed to be the center of the scene. We can actually set this back to 0 so we can keep looking at the other nodes. All right, now a very common practice in materials is to convert these constant values, these hard-coded values, into parameters so we can create multiple instances of this material where one might have a different color, one might have a different value for the metallic, the roughness. The way we can do that is simply by right-clicking on a node, convert to parameter. It's going to prompt us to name it, so we'll name it something as simple as color. And we can do the same for the metallic. So if I convert to parameter, name it metallic, roughness, name it roughness. And we can call this one over here emissive intensity. If I could spell. All right, so now if I save, we can now actually go back to our content browser and we can right click on this material that we made. We want to go up to create material instance. And the naming convention for material instance will be mi underscore test underscore 1. Now that we have an instance, we can double click that and you'll notice that the menu is a little bit different. You can see right away that we have the things that we named: emissive intensity, metallic, roughness, and color. Now by default, these will be checked off because it will use the values that are set in the material graph. But if we go back to the instance and check all of these on, now we can go ahead and start playing with the material. You can get lost in this, and it's really fun to try out different combinations of numbers and see what you can come up with. So let's set the roughness to something a little bit higher. All right, right away we kind of lose the reflections, but it definitely still looks pretty metal. Let's lower this back down to something like 0.4. All right, nice brushed metal there. And if we set emissive intensity, remember we can put this value pretty high, so that kind of gets blown out. We can try a value of 1 or 2. Now we have this sort of glowing blue sphere. Now just to showcase how simple it is to use a material instance, you can just drag it onto anything. You can see instantly that this material actually lights the walls around it. This is because of Lumen. Lumen is a new feature with Unreal Engine 5, and it basically lets the emissive materials emit light around it, and it goes into the scene and the lighting. It can really help bring a little bit more atmosphere to your scene. All right, so the next thing that I want to do really quickly is get a better model to visualize the materials on. So what we'll do is we'll minimize this. We can click on our gun here. We'll go to skeletal mesh and we'll browse to that asset. So now we have the skeletal mesh instead of the blueprint. We can drag that up into our scene. And now we have a mesh to put a material on. I'll just duplicate it one time. And then let's go back to the content browser, our materials folder. And let's actually duplicate the first material that we made, or the material instance. So I'll right click, duplicate. You can see it instantly names it test underscore 2. It knows that this is the second one and it tries to name it for us so we don't have to do it ourselves. Now if I drag this onto here and this one onto here, you can see that they're the exact same, but now we can open our second instance and you'll see that we have a separate control for this mesh. Let's go ahead and delete this cube, actually. It's kind of bothering me. All right, so now that we have two different materials, we can see the power of material instances that we can use to create multiple versions of the same graph. Both of these materials run on this graph, and any changes we make or parameters we add for more control can be used for the same material instance or any duplicate of itself. All right, now that we've seen how to use material instances and how that's useful to create different versions of the same material, let's go back into our graph and add a texture. We can right click and search for texture, and we'll get a texture sample. All right, now that we have a texture sample node, we can go ahead and from the drop down menu here, search for noise. Let's use T-Noise 01. If we plug this directly into base color, you'll see that the material instantly starts to use this texture for the color information. And if we save and go back to our scene, we can see this sort of cloudy texture coming through. Let's go ahead and set the default values of our emissive intensity to 0 so we can see more clearly what's happening. So now it looks kind of like a cloudy smoke texture on these weapons. Let's go ahead and now look at how to change the scale of this texture. As of right now, it's quite large on the gun, so we want to have a way to basically tile it smaller so we see the detail more frequently. Now let's search for a texture coordinate node. This red node here. All right, once we have this node out, we want to drag off and search for multiply. It's important to note that you can also hold M on your keyboard and click, and you'll get a multiply node. Again, this is a very common node to use, so that's why they have it as a shortcut. We don't need that, so I can delete it. And if we plug this right in, it's still multiplied by 1 and save, you'll notice that there is no change because it's using the default UV space of the weapon multiplied by 1. Anything multiplied by 1 is just itself, so that's why we have no change. Also, it's important to note if you don't have anything plugged into the UVs, it will be the exact same because by default, it's just 0 to 1 in the UV space. So if we want to change the scale, we have to add these nodes, and then we need a parameter to multiply so we can change the scale. So if we right click and search for a constant, we can plug this in, and then we'll right click and convert it to parameter. Let's call this the UV scale. And we'll set it to a default value of, let's say 4. Now if I save, you can instantly see that the texture is more compressed and smaller so we can see the detail much easier. Now on each instance, we can go ahead and change the scale. So if I wanted to, for example, make this 120, now we can see that it's very obvious the difference in the scale between the two weapons. All right, this looks kind of cool, but let's add some color back into it. So how do we do that? Well, we want to multiply the texture by the color. Now anything multiplied by 0 or black will, of course, stay black. So that's why when I save and go back to the graph, we can see that some parts are still the original color of the texture, which is black, and the other parts are whatever color we have set on our instance. So this is the material instance test 1 that we set to blue. I could set it to green, reddish, and then this other one here, it has a different scale, and we could set this color, to something like this. So now we still have this control over the color, and now we can change the scale of the material. We're going to look at how to pan the texture now, which is another term for move the texture along the UVs. So if we right click and search for panner, we can plug the coordinates. Remember, this is a texture coordinate node. This is basically how to manipulate the scale of the texture, and we're multiplying it by a value to change the scale. We can plug those coordinates into coordinate here, and then this output will just replace the UVs there. By default, we won't see any change, and that's because the speed here is set to 0. Now, it's important to note that this is X and Y. So we can't just plug in a constant value because this is just one value. But what we can do is have two of these, and then we're going to append them together. So we can search for append vector. And when we put these in together, we're basically saying this is the X and this is the Y because this is in the first and this is in the second. So now if we plug this in, it's the correct values. And let's just set some default values here. So I'll set 1 and then we'll leave this value at 0. Now when I save, go back, now you can see that the texture is moving along the x-axis at a speed of 1. All right, now that we can see the effect happening, let's go ahead and convert these two parameters. So this is the x-coordinate speed, and this is the y-coordinate speed. So we can name it speed x, and this one we can right-click, convert to parameter, and name it speed y. Now if I save and go to one of our material instances, we have two new parameters here, speed x and speed y. I set this value to, let's say, something crazy like 10. You can see on our instance here, it's going extremely fast, probably too fast. So let's try something like 0.1. Now it's really nice and slow and smooth. If we also change the value of speed y to something, let's say 0.5, now the texture is moving 0.1 speed to the x UV, which is going horizontally, and on the y it's going 0.5. So it's mostly going upwards, and then it's slightly going to the left as well. If we set speed x to 0, it's only going to go upwards. And if we set speed y, to something like 10, you'll see that extremely fast effect going upwards. Our other instance is still just set to 1 on the x. So we can change this to, let's say, negative 0.5 and negative 0.5. Now we're going the opposite direction on both axes. So we get this different effect where it's sort of going downward. All right, now that we've learned how to animate the texture in a certain direction, let's go ahead and look at a new concept called linear interpolate. This is a very important node that's used in almost any material, and it's a way to interpolate between two values, value A and B. You can do this smoothly over time, or you can use a texture. You can set the value to be a specific number. For example, it's 0.5 by default. So it would basically mix value A and B together. We can visualize this by, we'll duplicate this color here, and we'll call this one, change the name to color B. And if I just drag color A into A and B into B, but this is the base color. And if I save, go back to the material, look at this instance here. If I set this value to blue on that, and then let's say red on this, now we have purple. Because in our linear interpolate, the value is simply set to 0.5. So it's half of A, half of B. So it just mixes the two together. But what happens if we use a texture that is black and white as the alpha? In a texture where it is black, it's basically 0, and where it is white, it is basically 1. And this texture has values that are in between 0 and 1, such as maybe 0.5, 0.2. It's all the gray values in between. So if we plug this in, this RGB into the alpha and save, now we'll get an interesting effect where we have this sort of tie-dye material. And if we go into our colors and mess with them, we can really get some interesting stuff. So let's just mess around. We'll try greenish and blue. Set this to be kind of darker. Oh, this one looks pretty cool. Let's still open it and change some of the stuff. We can try white and like bluish. All right, now that we've seen how to use a texture to interpolate between two color inputs, we can also test it on a thing like the roughness. So if I plug this roughness into A here and duplicate roughness, we'll call it roughness B. Then we can have this on A, roughness B on B, and then we can just drag in that same texture into the alpha. And then if we plug this into roughness, save, go back to our material instance. Now we have roughness B. Let's set it to something drastically different from the other. So we'll do 1 for roughness B, and we'll set roughness to 0. So now you can see that the texture is actually giving us differences in how shiny it is, as well as the color. All right, let's go back to our material. Let's kind of clean it up a little bit. I'm going to move this over here, straighten this up, this over. And remember, our emissive color should be the color from our base color. So instead of just plugging in this color multiplied by intensity here, we actually want to use this color information to multiply. Move this over so we can move these colors up here. All right, now that we can see ways to change the animation of the texture, the scale of the texture, the different colors of the texture, and even the different roughnesses, let's look at a way to change the texture on each individual instance. So we need to convert this to a parameter. If we right click, convert to parameter, now we can name this, we'll call it texture A. All right, now if we save and go back to our material instance, we can click this drop down, global texture parameter values, and we'll check this on to be changed per instance. All right, looks like I'm on this material instance here, so we'll go over here and we can search from this drop down. Let's just change it to a different texture. Let's try Perlin mask. Now you can see that this texture is much softer and doesn't have as much contrast, so the effect isn't as noticeable as when we had the other texture. All right, the next concept that we're going to go over is the normal map input. So we have normal input here. We're going to go ahead and we'll full screen the material, move this over here a little bit, and we can drag off of this and search for texture sample parameter 2D. This will allow us to name the texture as a parameter right away. And now that we have this texture, we can go ahead and search down here for FP gun underscore N. So this is the normal map that came with the gun from Epic Games. This is the one that's actually on this weapon here. If you zoom in, you can see what I'm talking about with the fake shadowing. So this line here isn't actually modeled geometry. It's the normal map doing it for us. Because this detail is so minimal and small, it would be a waste of performance to actually model individual triangles to give this sort of fake depth. So let's go back over to our weapons here. All right, so we want to basically save our material here, and then we can zoom in and we can see we got right away that fake detail that really helps sell the model and give it that realism. All right, now that we have all of this cool control for our material, what I want to do is make our material instances a little bit more organized. As you can see here, we have these drop-down menus called global, scalar, parameter values, texture parameter, etc. This isn't very user friendly and can get quite confusing very quickly. So what we'll do is we'll go back into our material. All right, so once we're back in our material, we can go ahead and highlight any node that is a parameter. So for example, we have color parameter, and then over on the left in the details panel, we can go to group. By default, it's set to none because we haven't named any. We can just highlight this and we'll call it base color. And then we can highlight all of the other nodes that we might want to put in this category. And now from the drop down, there will be base color. Now, if we save and go back to our material instance, you can see we have a new group with everything that relates to our base color input, which is everything that's going into here. The last thing we need to add to it is the texture. So we'll just click that, drop down, base color, and save. Now everything for the base color should be here. The colors at the top, pretty important. UV scale at the bottom. All right, so we're getting somewhere. Next, we want to put these in a group as well. So let's go ahead and highlight metallic, all the roughness, and we'll call this, we'll call it adjustments. If I could spell right. All right, and then finally, well, actually we have two more. We have the normal and the emissive. Let's put the emissive in its own category because we'll add some more stuff to that later. So we'll do emissive and normal, we'll call it. All right, so now if we save and go back to our material instance, you can see we no longer have a global parameter drop down. We have adjustments, base color, emissive, and normal. All right, so now we have a nice and organized material. We have a bunch of different controls for changing things like the texture. We can lerp between two different colors. We have the normal map to give the fake detail, and we have some adjustment parameters to change simple things like how shiny the material is. All right, the final concept I'd like to go over with you guys is how to clean up your material graph a little bit. So we can see here that we have some spaghetti going on and we want to clean that up as much as we can. Let's actually drag off of a node where we're using it more than once. So for example, this color output we're using in the base color and we're also using it to multiply by the emissive intensity into the emissive color. So drag off of this lerp and search for reroute, and we'll do an add named reroute declaration node. This allows us to name whatever this information is, and we can use it in other parts of the graph. So we'll call this base color. Now that we have this named here, we can right click, search for base color. It'll always be at the top, and we can just plug this right in. And we also need to use it for the emissive. So we'll right click, search base color, and connect all this up. All right, it's looking a little bit cleaner now. Another version of this that could be useful is dragging off of RGB, and we'll call this, well, first we have to search for add named reroute, and we'll call this texture. Now we can search for texture. This one we will have to scroll all the way up. It will be at the top, and we can plug this right into here. Get a little bit more space. And you could just drag off of this and put it here. It's the same thing, but what we'll do is search for texture again. Plug this in here. Now we can select all of this, drag it up top here, move this stuff down a bit. Oh. And just like in blueprints, we can add a comment box. So by selecting all of these and pressing C on our keyboard, we can go ahead and name this what this is. So this is our texture mask, because we're using it to mask between two different effects. So for example, we're masking the area where we'll use this color versus color B, and we're also using it here to mask between the roughness and the roughness B. So now we don't have as many crossing wires, and it's a little bit more organized, so we can go ahead and save, and we'll go back to look at our materials. All right, guys, so you've learned how to make your first master material and various instances that you can play around with and change things like the color or the texture that's lerping between the two different colors, and you can get some really interesting results. What I encourage you to do is play around with this material, try different things. You can always duplicate this lerp, and you could lerp between different intensity values. For example, if I drag this stuff over here, instead of plugging the emissive intensity directly into the multiply, we can use this as the A, and we can duplicate emissive intensity B, and then we'll use the same texture as the alpha between the two emissive intensity values. So now if I save and go back to one of the instances, you can see we have this new parameter, emissive intensity B, and if I set this to 1 on that one, and if I go to this instance over here and change this one also to 1, you can see that only where this texture is white, here it's going to increase the emissive intensity in that area. And remember, this value can go above 1, you can set it to 10. You can really go crazy with these values and come up with some really, really cool stuff. So that's going to do it for this tutorial. Make sure to leave a like and subscribe. And again, let us know down below what kind of material that you'd be interested in learning about next.